Hello all, welcome to our next session in transportation engineering. We are in the topic of geometry design under highway engineering. This session we will be solving problems related to setback distance and curve resistance. I hope you have seen the theory topic of curve resistance and setback distance. Okay, so this will be a continuation of that. So you see this question number 24. I hope you remember we are continuing the questions from 1 till the topic 1 and we are continuing the numbers. You can, I hope if you are following, then you should also have the number of question number 24 with you. Okay. Okay, so the assuming safe stopping distance, they have given a question safe stopping distance to 80 meter on a flat highway section, and they have given even a setback distance also. They have given a setback distance of 10 meter. What would be the radius of the negotiable horizontal curve? Okay, so they have given the radius, they are asking the consider, they have given the setback distance and they have given the stopping side distance 80 meter. Okay, and they have given a plain terrain, that is okay. So they are asking the radius 800, 160, 80 and 70 meter. Okay, this part can be easily solved. You can even solve with the geometry, but this part can be very easily solved using that approximate formula if you remember. So if you see, they have given, give me a second, they have given setback distance 10 meter. Okay, and they are asking the radius. So radius is equal to, so they have given setback distance 80 meter, sorry, side distance 80 meter, setback distance 10 meter. We know the formula s square by 8r. Okay, so if you see, s is 80 square divided by, you can bring the r that side and setback here. Solving this, you know, 80 square means 80 into 80 divided by 80, so you will get 80 meter as the radius. Very simple, right? So this problem I have given you only to understand the approximate formula, how to adapt. Okay, so option C is your answer. Okay, so the next question, this is, will make it little more complicated. There is a horizontal circular curve with a center line radius of 200 meter. Okay, they have given the radius on a provided is provided on a 2-lane 2-way section. Okay, so the number of lanes is 2. The width of the 2-lane road is 7 meter. Okay, they have given that width is 7 meter. Design speed for this section is 80 km per hour. They have given the V 80 km per hour. Brake reaction is 2.4 seconds. Okay, they have changed it. Should be P as per PAEV should be 2.5. Okay, coefficient of friction for longitudinal friction 0.355 and lateral friction 0.15. Okay, I think it's a very detailed question. First question they are asking is safe stopping side distance. They are asking you to determine SSD, and then they are asking the setback distance from the center line of the inner lane. Okay, so this is, you should remember, this is the critical word. They are asking from the center line of the inner lane. Okay, so first let us find the safe stopping side distance, and you remember they have given 2-lane 2-way traffic, 2-lane and 2-way traffic. Okay, so you no need to determine the ISD, right? It is a 2-lane road and one traffic is going in this direction and other traffic is going in this direction. So 2-lane 2-way traffic. So only we have to find SSD. We know the formula SSD is Vt plus V square by 2Gf. V is converted from kilometer per hour to meter per second by 0.277 into 80. Reaction time is I think it's a 2.4 seconds. It should be okay. Anyhow, verify the question whether it is 2.4. It should be 2.5. Okay, so 2.4 into V square is 0.277 into 80 whole square divided by 2Gf. Okay, I think I did so 2 into, oh okay, I have written correctly, but to make it more clarity, 2.81 into friction is 0.355. so you solve this, approximately you will get 126 meter. Okay, this is your stopping side distance. And then, so the first question is over. The second question they are asking is, or they are asking the setback distance from the center line of the inner lane. Okay, so first let us find, this is a multi-lane road. Okay, so first you should know the distance. Again I will draw in. So this is a 2-lane road. Consider the center of the inner lane is this one. So if you remember, this is our small d. So the d is the distance between center line of the road to the center of the inner lane. What it can be? So if the total width is given as We know the total width is given in the question as 7 meter. So 7 by 4 will give you 1.75 meter. Okay, that is your small d. So keep it aside. Let us find first setback distance from the center line of the road. Okay, so to determine from central line of the road, we can use the same formula what we know, r minus d cos alpha by 2. Okay, so you can use r radius 200 minus 200 minus 1.75, cos alpha is 35.9. okay, whether it is given. Okay, so I think you have to find the alpha also. Give me a second, I will determine this one with this. 1 second. Okay, so you should use this formula to determine the alpha value. Okay, so find the alpha value. After finding the side distance, I think I missed some step. You can do step 2b to determine this alpha value. Find this alpha, you should get this 35.9 degree. Then you can come back to the formula and determine r minus d cos alpha by 2. You will get this formula. You apply, you will get 11.4 meter. But this much distance you should clear from the center line of the road. Okay, but they are asking from the center of the inner lane, right? Center line of the inner lane. So you should subtract that d value. Okay, from the setback distance also you should subtract that d value. M minus d will give you the setback distance from the center line of the inner lane. If they are asking from the outer lane, center line, consider, take it as a note. If they are asking center line of the road to the center of the outer lane, there will be outer lane. If it is a 2-lane road, there is an outer lane also, right? So then consider, I can even show you in a figure. So we know the setback distance is calculated from center line of the road. When they are asking the setback distance from the outer lane of the road, center line of the outer lane of the road, then what you should do? You should try to add this one. It should be m plus d. But when they are asking with respect to center of the inner lane, I hope you know this is also d only. So what I am doing here, I am doing m minus d. Clear? If they are asking with respect to center line of the road, it is only m. If they are asking with respect to center of the inner lane, it is m minus d. If they are asking center of the outer lane, then it is m plus d. Okay, solving this you will get to your answer 9.77 meter. Okay. So the next question, find the minimum setback from the building of the from the building to the center line of the road. If the radius of the center line of the road is 600 meter and the side distance is given as a 200 meter. So radius is 600 and side distance is 200 and they are asking from the center line of the road. Okay, so radius is 600, side distance is 200. Since nothing is specified related to length or something, we will always assume length of the curve is greater than or equal to s. Okay, so step 1, obviously you have to find your alpha value. For length is greater than or equal to s, if you remember, alpha will be equal to 180 by pi s by r. S is given 200, r is given as 600, which will give you 19 degree. You can do this algebra. Step 2, then you can use the formula r minus r cos alpha by 2. Since it is a single lane, they didn't give you anything related to lane. So, and they are asking with respect to center line of the road only. So you can directly use the formula r minus r cos alpha by 2, which will give you 8.3 meter. Okay, so this is your setback distance. Next question, question number 28. Calculate the setback distance from the obstruction to the center line of the road. Again, same type of question. And if the radius is 450 and the side distance is 300 meter, length of the curve is 200 meter. Okay, now they have given even the length of the curve, and you see the length of the curve is 200 and side distance is 300. So the length of the curve is actually less than the side distance. Okay, so then we have to use the other case. The side distance is greater, right? The length, right? So anyhow the same step 1, but in this case the formula is L by R. And remember, again they are asking with respect to center line of the road. If they are asking with respect to center line of the road, you can directly use the single lane type of formula. And in this case, whichever is lower case, always that will come as a numerator for finding the alpha. Okay, 180 by pi I multiplied to get a degree. Alpha is L by R. You substitute everything here, you will get 25.46 degree. And we know the formula m equal to r minus r cos alpha by 2 plus s minus L divided by 2 into sin alpha by 2. You substituting, I hope you remember how we got this formula. Everything is known. We know r, we know alpha, s, L, alpha, everything. You just substitute everything, you do the algebra properly, you will get 22.08 meter. You can pause the video and do the algebra yourself. Okay, so this is quite simple. Okay, one more question. Question number 29. I think this will be from my side the last question for setback. Overtaking side distance is given 225. The radius is 350 meter. And the length of the curve is 175 meter. Okay, so the distance between center line of the road and an obstruction on the inner side of the curve for safe overtaking is dash. Okay, this is the setback only they are asking. Okay, don't get confused. They are asking the setback from center line of the road, okay, and an obstruction on inner side of the curve for the safe overtaking is dash, and they have given the width of the road 8 meter, and also calculate the clearance distance between inner edge of the road and a building to be constructed. Okay, so you see the given radius is given 350 and OSD, don't get confused, OSD is nothing but S, you can take it is just a side distance, and the length is 175 meter, width of the road is 8 meter, so we can assume it as a two lane road, and we know the formula D is divided by 1 by 4, right? I have shown in the previous problems the D, the inner clearance distance, we can take it as 8 by 4. Okay, and since it is two lane road, we can also assume it as a multi-lane road formula we are going to use. Okay, and I hope you know this. I have drawn this figure so many times. This you can say it as a D by 4, sorry, total width divided by 4, which will be the D value. Okay, let us assume, okay, you no need to assume, we can even see S is greater than L. Okay, so the step 1 will be to find the alpha value of our case. So it will be for multi-lane road 180 by pi into L by R minus D, length of the curve we know 175, divided by 350 minus 2, you can substitute, you will get 28 degree. So you can take this formula, I hope you know this formula, right? For S is greater than L, we know this formula, R minus D cos alpha by 2 plus S minus L by 2 sin alpha by 2. When substitute everything, you will get answer with respect to central line of the road. That is your first question answer. And they are asking the clearance distance between from the inner edge of the road, they are asking, right? Obviously, as I told you, whatever they are asking with respect to inner edge of the road, which is nothing but you have to take divided by 2, I have to take. Okay, I am not subtracting with respect to inner edge they are asking. Okay, consider the road is here. If they are asking with respect to inner lane, okay, center of the inner lane, we know from here it is M, and we know this is D. Okay, and you should know this is total width is 8. Okay, and we know this is D. So the setback distance is being calculated from here. So if they are asking with respect to inner edge, we should subtract this one, right? 8 by 2 we should subtract, so that we will get from inner edge. Understood? If the total distance, this is M, and this distance I should subtract, this distance is nothing but B by 2, that's what I am telling you. B by 2 is nothing but 8 by 2. So I am subtracting 8 by 2. Sorry, this is B. Since they are asking from the inner edge of the road. If they are asking from inner center of the inner lane, then you should do something else. What you should do? You should subtract the minus D. Like how I showed you two problems before. You should subtract from the setback distance minus D. In this case, they are asking from the inner edge of the road. So I am subtracting by the minus B by 2. Okay. So try to remember again, whatever you are doing with respect to whatever formula we have derived is with respect to center line. First find that. Whenever whatever be the problem, find the with respect to center line. Then from where they are asking, you try to understand the question clearly, then subtract that one from the M or add that one to the M. Okay. Okay. So next question. If the turning angle is 45 degree, what is the ratio of loss of tractive force to the original one? So they are asking this ratio, loss of tractive force to the original one. We know the formula laws of attractive force is P minus P cos theta. If you take common P into bracket 1 minus cos theta divided by P, you can cancel PP. So 1 minus cos theta, 1 minus cos 45 degree, which is 0.47. So loss of attractive force is how much we are losing? 0.47 times of the original force which we should have received. How much we are losing? I understood, almost 50% of the force you are losing. Okay, that's the question number 30. The answer is 0.47. This is question number 31. If the turning angle is 90 degree, if I turn the turning angle is 90 degree, what is the what is the curve resistance? So the curve resistance is equal to P minus 1 minus cos 90 degree. Cos 90 degree is 0, so 1 minus 0 is 1, so you will get P. The curve resistance, total force is resisted. Okay, the loss of attractive force is everything you have loosened. You lost everything, that's what it means. So you will get the total, the curve resistance is P. Okay, so with this we have completed the session on horizontal curves and also on the straight roads. Okay, from next session you are going to see the vertical alignment. In that we are going to see the gradient, summit curve and valley curve. Okay, thank you. See you in the next session.